Okay, good day. This is Math 130, Introduction to Statistics. I am Professor McCulley, and this is lesson number 6 on mean, median, and mode. So let's get right to it. Today we are talking about measures of central tendency. They are the mean, median, mode of a population or a sample. And then we are going to find a weighted mean of a data set and the mean of a frequency distribution, which is essentially the same thing. And then we're going to describe the shape of a distribution as symmetric, uniform, or skewed, and then compare the mean, median, and for each. All right, so definitions here. We're first, the mean of a data set is the sum of the data entries divided by the number of entries. So the population mean, which will be signified by the lowercase Greek letter mu, and it is the sum of the x values divided by the total population, and then the sample mean, which we're going to call x bar, is equal to the sum of all of the x values divided by the sample, the number in the sample. And I went over these things. So again, this symbol is the lowercase mu, and this symbol right here is is pronounced x bar. This symbol here is the Greek uppercase sigma, and it implies a sum. Again, n is the number of elements in the population, whereas lowercase n is the number of elements in the sample. The median of a data set of the value lies in the middle of the ordered data. The median divides the data into two equal parts. If the data set is even, then the median is the average of the two middle values. The mode of a data set is the entry that occurs the most often. A data set can have multiple or no modes. When two modes occur, the data set is said to be bimodal. And as a note, the TI-84 does not find the mode, so you're still going to have to do that one by hand. Definition: an outlier is an entry in a data set that is far removed from the other values of a data set. For now, the eyeball test is okay, but we will have a formal way to find out outliers later. And again, and especially when you're talking about mean, the outlier usually throws off the mean by quite a bit. That's why when you talk about how property values, they usually use median for property values, because if you have a bunch of lower priced homes in an area and then you have two or three that are like really expensive, it can throw the mean off by quite a bit. Finally, the mid-range is the average of the maximum and minimum value of a data set, but this is very rarely used. So let's see here. Let's use our graphing calculator to find the mean, median, and mid-range and mode for the data set. All right, so first thing we're going to do is we're going to pull up our graphing calculator, and currently it's got nothing on it. And again, we're going to use this stat button to get there. And so when I hit stat, the first thing we're going to do whenever we enter data into it, we're going to edit. And our first thing we're going to do is we're going to clear the list. So I'm going to hit 4 to clear the list. And I'm going to put my data in L1. So I'm going to hit L1 right there. And we'll hit enter. It'll say done. Now we're going to hit stat. We're going to hit 1 for edit, and you'll notice it cleared out L1 even though I had some data from the last presentation still in L2. So I'm going to use my arrow key to get over there, and then I have to go back here and enter this data by hand. So 28, 30, 28. So 28, 30, 28. Oops, I don't want to do that. Let's delete all this. So 28, 30, 28. And then let's go back here. 31, 31, 28. 31, 31, 28. And then, let's see here. 33, 30, 38. 33, 30, 38. And then, let's see here. 34, 34, 32, 34, 34, 32, and then let's see here, 27, 34, 28, 27, 34, 28, 27, 34, 28, and 30 or 23, 18, 30, 23, 18, 30, 23, 18, 30, and two 30s there, two more 30s, I suppose. And so since this, if I was to put another piece of data in there, I'd have it, that'd be my 21st piece of data. So just as a real quick, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. As long as I didn't make any errors, I should be okay. All right, so the next thing that we're going to do now that I have my data in there, I'm going to hit quit, or second and then mode, which brings me to quit. I'm going to hit that stat button, and we're going to go over to calculate. All right, so there's a lot of stuff going on here, and we're going to use a lot of it. And even the thing that I'm going to show you today, we're eventually going to have to talk about all of the parts of it. And I think in the next lesson, I will make a list of everything that's there. But we're just for today's stuff, we're going to shorten up and just look for what we're looking for. And so I want to do these one variable stats. And so I just want one. So I'm going to hit enter. And the default setting is the list is L1. That's where we put our data. The frequency list is defaulted to be nothing. And on our next example, or one of our next examples, we're actually going to fill this in when we're doing the weighted example. But the default is to leave that empty. And so we're just going to hit enter. We're going to leave that empty and hit enter there. And then we're on calculate. We're going to hit enter. And we see a lot of this stuff. And so right off the top, we see this X bar. And even though we don't know if this data set is a population or a sample, it doesn't make any difference because they're calculated the same way. Now, some of these are calculated differently. This is the standard deviation of the sample, and this is the standard deviation of the population, and those are a little bit different, but we'll talk about those later. And so right off the top, we can go to here, and we're trying to find the mean. So our mean is, let's see, what do we come up with? 29.85. 29.85. Our median, well, where is that? That's also on here. So if I use my down arrow key, I've got these 5 variable stats, which we're going to talk about in detail later. But right here is MED, that's your median. Your median is 30. My mid-range, okay. So my mid-range, if I look here, I have my min and my max. And so my mid-range was if we look back, right here is the definition, the mid-range is the average of the maximum and minimum values. So right here we see a minimum value, we see a maximum value. So I'm going to take 18 and 38 and average them. So we'll call it MR equals 18 plus 38 all over 2. And I'm just going to do that with a calculator I have sitting here real quick. 18 and 38 is, clear that out. 18 and 38 is 56 divided by 2, which is 28. And then the mode is the most often occurring. So 28, well, I see 1, 2, 3, 4 28s. 1, 2, 3, 4 28s. And 1, 2, 3, 4, 5 30s. 1, 2 31s. 334s, but I see 530, so I want to say that my mode is 30 because it occurs 5 times. Which is the most. All right, let's move on. Definition, weighted mean. Weighted mean of a data set whose entries have varying weights. The weighted mean is given by, so x bar, this mean is the sum of all of the x values times the weights that they are given, divided by the sum of the weights, where w is the weight of each entry x. Okay, so let's look at an example for how I'm going to use this particular function right there. So suppose you're taking a class where there are 4 different grading categories and each were weighted differently. Let's say that tests were weighted as 40% and your average on the 4 tests was 85%. Your midterm was weighted as 20% of your grade and you scored a 75 on that. Your final was weighted as 25% and you scored an 80. And then finally, your homework was weighted as 15% and you averaged 100% on those homeworks. Find your weighted average. So the first thing we're going to do is we're going to make a table. So I'm going to insert a table here. I need, let's see here, I need 3 things. Yeah, I need a category, and then I got my, so I want to label the top. I want to have my 4 things plus a sum at the bottom. Let's go with that. Let's see, I think that'll be right. All right, so here I'm going to call this category. This I'm going to call score or average. And this one I'm going to call weight. And then this one I'm going to call, and so this one is my X. I'm going to call this, and this is going to be my W. I'm going to call this X times W. And so we have tests, we have the midterm, we have the final, we have homework. All right, so my score, I had on my test, my score was 85%. On my midterm, let's just put in the weight. So I've got the weight was 0.4. And then the midterm, let's see here, my midterm was weighted as 20% and I scored a 75. So the score there was a 75 and 0.2 for that one. On my final, I did a little bit better. We did an 80 and that one was for 25%, so 0.25. And in the homework, we did 100 and that was worth 15%, so 0.15. And so if I add these up, because I weighted as percentages, and it doesn't have to come out this way, it doesn't have to come out that way. You can weight it however you want. But since we did it as percentage of a total grade, it should come out to be 100. So 4 and 2 is 0.6. 0.25 and 0.15 is 0.4. 0.4 and 0.6 gives me a sum of my weights, sum W equal to 1, but that doesn't always have to happen. And so we want to calculate X times W, so just the value in the score column times the weight. So let me do that. I'm going to do that separately. So 85 times 0.4, that gives me 34, and then 75 times 0.2, that gives me 15. Oops, 15, and then 80 times 0.25. Oops, did that wrong on my calculator, sorry. 80 times 0.25 is 20, and then 15, 100 times 0.15, I don't need a calculator to do that, just move the decimal place twice, right? So 100 times 0.15, which should just be 15, and then the sum, let's do a better job, of X times W, would be this sum here. So 34 plus 15 plus 20 plus 15 is 84. So my x bar is the sum of x times w over the sum of w, which in this case was 84 over 1, or 84%. You get a B for your final grade there. All right, so finally, use the graphing calculator to find the weighted mean from the previous example. So the weighted mean is, and just to go back here, the weighted mean or the mean of a frequency distribution, this is going to be the same thing. And so to do this, we're going to grab our graphing calculator, and since it's a new statistical analysis, the first thing we're going to put new values in. The first thing we're always going to want to do, we're going to hit that stat, and we're going to clear those lists out. So I'm going to hit 4 to clear the list. Now I need 2 lists this time. So this time I'm going to go L1. I got to hit that comma button, and then second, and then 2 for L2. That's going to clear out both of those data sets, and then stat, and then we're going to edit. Now, in this time in L1, we're going to put let's go back to here. We're going to put the score column. So we're going to put this data set here, 85, 75, 80, 100. So 85, 75, 80, 100. And then in this list here, we're going to put in the weights. So the tests were worth 0.4. The midterm was worth 0.2. The final was worth 0.25. And then the homeworks were worth 0.15. Hit enter. Now I have my table entered. We're going to quit out of that. Then we're going to go hit just the stat button again. This time we're going to go over, and again we're going to hit the one variable stat. So I'm going to hit 1 for one variable stats. I still put my list of values in L1, but this time now my frequency list is L2. So I have to enter that in. So I'm going to go second and 2 to get L2 in there, and hit enter. We're going to hit the calculate button, and now our X bar is 84, which is what we found in the last one. So again, X bar equal to 84, which is what we wanted. So we're going to finish up this section with talking about data and how data is distributed. And we're going to come up with some names of graphs, and then I'm going to go over the definitions here, and then in the next screen we will draw some pictures that kind of match up. So first we got symmetric data. If the data is symmetric, then the distribution of the data to the left of the mean approximately mirrors the distribution of the data to the right of the mean. Uniform data, a set of symmetric data where each class has approximately the same frequency. Skewed data. Data is going to be skewed to the left if one tail of the data is elongated to the left, and data is skewed to the right if one tail of the data is elongated to the right. So let's take a look at what some of this stuff means. And so first, let's take a quick look here at symmetric data. So if I put, and we're going to call that little green dotted line the mean value, and if I wanted to draw in symmetric data, essentially I'm going to get a value so that when I look at what's on the left side, I am going to approximately get the same thing on the right. Now it's not going to be perfect, but we're going to get essentially the same thing. Now uniform data is still symmetric. It's still going to give us something that looks where it's same on the left as it is on the right, but what we're going to end up getting is data that is going to be the same frequency at each level. Skewed left and skewed right are a little bit different though, and so when they say it's skewed left, the tail is going to be elongated to the left. And so if we talk about this first symmetric, this is a tail over here on the left hand side, and this is a tail here on the right hand side.
So if data is going to be skewed left, then that tail on the left-hand side is going to be skewed, or is going to be elongated. So what we're going to get is a graph that's going to kind of look like this, because that tail over there is elongated. Now, is that in skewed left data, the mean is actually going to be a little bit to the left of the median. So the median is the point that's in the middle, and so the amount of data on the left-hand side and the amount of data on the right-hand side are going to be the same. But the median is going to be a little bit over here because it's elongated to the left. And when you have skewed right data, the skewed right data is going to have a tail that's elongated to the right. And that's all I got for today, folks. So
Today's Marvel fun fact of the day: in the original Thor movie, we see a glimpse of a completed Infinity Gauntlet during the scene where the Frost Giants break into Odin's vault. To reconcile this break in continuity, Cate Blanchett's character Hela decries it to be a fake when it appears again in Thor Ragnarok, like 6 years later. So that's all I got today, folks. You have a good day. Goodbye.